Hello and welcome to the session. In this session we discuss the following question which says, if q is a prime number, then prove that square root q is irrational. Now, to prove that square root q is irrational where q is a prime number, we'll use a result which says that let p be a prime number if p divides a square, then p divides a where a is a positive integer. This is the key idea to be used in this question. Now we move on to the solution. We are given that q is a prime number we need to show that square root q is irrational. We take let square root q be rational, then we can write square root q in the form m upon n, where m and n are integers having no common factor other than 1, and also n is not equal to 0. Now that we have square root q is equal to m upon n, so this means that q is equal to m square upon n square. We got this on squaring both sides. So this further gives us q into n square is equal to m square. Now since we know that q divides qn square, therefore we have q divides m square, since qn square is equal to m square. Now using the result given in the key idea which says that if p is a prime number and p divides a square, then p divides a. So here we have q is a prime number and q divides m square. So this means q divides m, since q is a prime number and q divides m square. So this means that q divides m. So we take let m be equal to pq for some integer p. Now consider this equation, qn square is equal to m square. Let this be equation 1. So now substituting m is equal to pq in equation 1, we get qn square is equal to p square q square. This means we have n square is equal to qp square. Now since q divides qp square. Therefore, q divides n square, since qp square is equal to n square, and this implies that q divides n since q is a prime number and q divides n square. So this implies that q divides n. So now we have q divides m and q divides n. Therefore, q is a common factor of m and n. But this thing that q is a common factor of m and n contradicts the fact that m and n have no common factor other than 1. Because earlier we had stated that m and n are integers having no common factor other than 1. Thus, our assumption that square root q is rational is wrong. Hence we have that square root q is irrational. Thus we have proved that square root q is irrational. This completes the session. Hope you have understood the solution for this question.